In this video, we're going to have a look at how to calculate the volume of a composite 3D shape. To calculate the volume of a composite 3D shape, first you want to split the shape into individual shapes. After you've split them into individual identifiable shapes, you want to calculate the volume of each of those shapes. And then you want to finish off your calculation by adding or subtracting those individual shapes together to calculate the volume or the total volume of the composite shape. So let's have a look at an example to see how this is completed. So in this example, we want to find the volume of the composite shape shown in the diagram. Now the first step in calculating the volume of a composite 3D shape is to break that shape into smaller individual 3D shapes. So having a look at the shape in the example, I can see that I have got a cylinder and I've also got a sphere or semi-sphere that sits on top and a semi-sphere that sits down the bottom. To help me with my calculations, I have drawn a cylinder and a semi-sphere that I can go ahead and use in my calculations. Now that you'll note I've only drawn one semi-sphere and not two. That's because by looking at the measurements on the diagram, I know that my semi-sphere up the top and on the bottom is going to be the same shape. So instead of calculating them individually, I can calculate the volume of one and then times it by 2. So before I go ahead and start those calculations, I want to put in my measurements onto my individual shape diagrams. So the radius of my cylinder is 6 meters. The height of my cylinder is 11 meters. And the radius of my semi-sphere is going to be the same as my cylinder, which is 6 meters. Now that I have those marked in, I can go ahead and calculate the volume of each of those individual shapes. So we'll start off by calculating the volume of the cylinder. And that is going to equal to its formula, so pi r squared times h. Substituting in my values, so pi times my radius of 6 squared times my height of 11, which equals to 1244.07 meters cubed. So I can add that into my diagram. Next, I need to calculate the volume of my semi-sphere. Now I can calculate the volume of my semi-sphere by using the formula of a normal sphere and dividing the answer by 2. So the volume of my semi-sphere is going to equal 4 times pi times radius cubed divided by 3. That's my normal formula for the volume of a sphere. And then I want to go ahead and divide that answer by 2. So the next step is to substitute in my values. So 4 times pi times my radius of 6 cubed divided by 3. And then I divide that by 2. So doing the top part of my equation, my numerator, which is the volume of a sphere, I get 904.78. And because it's a semi-sphere, I divide that by 2. Which equals 452.39 meters cubed. And I can add that into my diagram, so 452.39 meters cubed. Now that I've gone ahead and calculated my individual components, I can go ahead and calculate the total volume of that composite shape. So the total volume is equal to the volume of my cylinder plus 2 times the volume of my semi-sphere. So substituting in the values, it's going to be 1244.07 plus 2 times 452.39, and that gives me a total volume of 2148.85 meters cubed. So the volume of the composite shape in the question is 2148.85 meters cubed. And that is an example of how we can calculate the volume of a composite shape by breaking it down into smaller individual shapes, finding the volume of those, and then adding them together to get total volume.